Now we're going to start looking at section 1.4, where we're going to be talking about performing operations on entire functions instead of just performing operations like adding and subtracting two numbers. So the most important part about this slide is really the notation. Whenever you see f plus g in parentheses and then the x, so they're saying f plus g of x, you can actually just think of that as the first function plus the second function in the same way that you would add two numbers like 3 and 7. Now you're going to have an entire expression like x squared plus 7 and then add to that something like 3x plus 2. So we're adding functions together instead of just numbers. Very similar notation. If they have f minus g of x, you can think of that as f of x minus g of x. When they have the dot in there, that indicates that you are multiplying the two different functions. And if you have f over g, that would indicate division, because fractions are just another way of writing division. I do have this separate comment over here that says g of x cannot equal 0. This is really just a reminder that you can't have 0 in the bottom of a fraction, because that would mean that you're dividing by 0, which is undefined. So there is a special restriction we have to consider for division that we don't have to worry about for the other ones, where g of x can't have any values to equal 0, or you would end up dividing by it. As far as domains are concerned, you will often be asked what is the domain of the combined functions. So after you add them, they'll say, what's the domain of that new combined function? Well, the domain is going to be the intersection of the two individual domains. By intersection, I mean if one is allowed in both f and g, then it will be in the combined domain as well. If there's a number that's not allowed in one of the functions, then it can't be in the combined function either. So the intersection means that it has to be in both of the domains for you to have it in the combined domain. And then the last little bit here is, again, just reminding you that g of x has an additional restriction. It cannot equal 0 since it's going to be in the bottom of a fraction. So whenever you have a dividing one, figure out the individual domains, figure out where they overlap, and then also go through and identify any where g would equal 0. So let's look at some examples and see if those rules will make more sense to you now. This question has asked us to find f plus g and the domain of that new combined function. Well, I have an f of x defined for me here. It's 4x plus 7. And I have a g of x defined for me. It's square root of x plus x. So if I am adding f plus g, I would have 4x plus 7 plus square root of x plus x. So we are really just describing the addition of these two functions, and then check to see if you have any like terms, and then you can combine to clean this up a little bit. In this case, I do have the 4x and the x. Those are both x to the first power, so I can combine them and get 5x. And then next, I would have the square root of x. There's nothing to combine with that. And finally, I have the constant 7. So now, instead of those two separate individual functions, we've found what happens if you add them together. And I've gotten this expression instead. So that's my f plus g expression. Now, there's another part of this question, though. They also wanted us to find the domain of this. Well, the domain for f of x was all real numbers. It's negative infinity to infinity. Because remember, we start off by assuming negative infinity to infinity, and then I look for any fractions or radicals. And this one doesn't have either, so my domain is negative infinity to infinity. For g, however, I don't have a fraction, but there is a square root in there. So for g, I need to remember that whatever's inside the radical, which in this case is x, needs to be greater than or equal to 0, because you cannot take the square root of a negative number. So in this case, my g domain is any number greater than or equal to 0, or in interval notation, that would be bracket 0 to infinity. So then we compare our two domains for f and g, and I'm looking for numbers that are in both of them. Well, this right here has eliminated any of the negative values. So the intersection, I can't use any numbers like -1, -2, -3 for the combined function either. So my combined domain for f plus g is just going to be all the numbers from 0 to infinity, because those numbers are included in both individual domains. The intersection is what's in both. This includes everything from 0 and up. Now here's a trickier example. Division is honestly the hardest one just because you have the extra domain restrictions to consider. I know that this is a division question because they have shown me f over g, which means I need to take the f function and literally just put it on top of the g function. So I would have x squared minus 9 on top of x plus 3. Now this function can be simplified because I know that x squared minus 9 is a difference of squares. So that actually breaks down as x plus 3 times x minus 3. And then since I end up with a matching factor on top and bottom, I can cancel out that entire factor. So my combined function is just x minus 3. Then we want to look at the individual domains for f and g. For f, my domain is all real numbers because again, I don't have any fractions and I don't have any radicals. So f allows every number possible. G's domain allows all real numbers because I don't have any fractions and I don't have any radicals. So if I was just looking at this, I would think that my domain for f over g is going to be all real numbers as well. But there's that extra restriction I gave you guys on the rules that says if you are doing division, then you also have to make sure that the bottom of your fraction does not have any zero values. Now, even though I got rid of the fraction eventually, my original expression does still have a fraction in it, so I need to make sure that I actually get rid of that -3 value. So for f over g, my domain needs to exclude -3, so I'm going to say all the numbers from -infinity to -3, and then all the numbers from -3 to infinity. So make sure you don't forget for the division questions, still look for the intersection of your two individual domains, and then also make sure you take out any zeros in the bottom. Don't just look at the final answer for that, look for every step of your work. Because if you cancel something out, that's still a discontinuity, it's still a value that you can't have in the domain, it's just that it was removed by some factoring and canceling. Here's one last quick example. This time I'm going to be multiplying, that's what the dot will indicate. Be careful on this because I'm actually dealing with a trinomial being multiplied by a binomial. So just saying FOIL won't work for this. That's why it's really more important to know the distributive property. So I'm going to be multiplying these two things out in detail. So this is going to be our f dot g function. So for the distributive property, start with the first term in the first set of parentheses and multiply it by everything in the second set. So I'm going to have 3x squared times 3x and then 3x squared times 1. Once you have taken everything from that first term and multiplied by everything in the second set of parentheses, then you can go on to the next number. So now in my first set of parentheses, I'm going to be focusing on the -11x. And I'm going to do -11x times 3x and -11x times 1. So distribute that out again. I'll have -33x squared minus 11x. So now again, I've taken that and multiplied it by everything in the second set of parentheses. So now I move on to the last term in the first set of parentheses. So -4 times 3x and -4 times 1. Now make sure you do look for any like terms. For example, I have an x squared and an x squared here, so those can be combined. I also have an x to the first power and an x to the first power, so those two can be combined. So we just want to simplify this as much as possible. So I will write my answer instead as 9x cubed and then +3 minus 33 would be -30. And -11 minus 12 more would give me -23. And the -4 is by itself at the end. Don't forget about that one as well. So just combine like terms, do any simplifying that you can. Now I have my f times g function. And for the domain, if I look at the domain of f, I don't have any fractions, there aren't any radicals, so it's all real numbers. And for the domain of G, I don't have any fractions, I don't have any radicals, so it's all real numbers. So my intersection, since both of them include every single number, there aren't any numbers I have to exclude in either one, my domain will be the same, negative infinity to infinity. And that's just telling me that there aren't any x values I'm not allowed to plug in. Basically, I can plug in anything, and I'll be able to get an answer. I won't have anything weird happen like dividing by 0. So that's all for the notes today. Thanks, guys.